Welcome to the Frictionless Utility Nanosatellite Concepts Network, also known as the FUNC Network. My name is John Claywork, and I had the distinct honor of being team leader for an excellent 2009-2010 Senior Space Systems Design project. I had 4 excellent team members. You will see all of them here shortly in the following interviews. What we ultimately came up with was a system of blowers, an air distribution converging duct. We have a 1-inch thick, 6 foot by 6 foot air table. We have a framework around it so that when we're testing nanosatellites, they will not fall off the table. And the table is adequately sized so that we can perform spin-up maneuvers. And for future, more complicated experiments, the faculty and grad students can perform rendezvous maneuvers. So now we're going to hear from each of our team members about the different aspects of this project. Stay tuned. Alright, welcome back to the FUNC Network. Of course, you all know me, I'm John. We are here with our research lead, Stephen Fisher. Of course, he had a major hand in researching a lot of the aspects, the major aspects of our project. So, Stephen, first off, what did you learn from doing this design and build project versus just a traditional design project?
Well, one of the best things about a design and build project is that there's actual hands-on experience. You get to work with materials and actually figure out a budget, and there's a lot of benefit to actually staying under budget and having a certain amount of money allocated to your team.
Very good, very good. What will you take away from this experience as you start your engineering career?
A lot of things. A true design team experience is one. Great friends as well. And just an interesting learning experience.
Cool. So now, the most important question, Stephen. Did you have fun this year?
Of course I did.
Welcome back to the FUNC Network. Of course, you know me, I'm John. This is Reed Goodwin-Johansson. He's our general design lead. So basically, Reed had a hand in all the general design aspects of each individual component that went into the project. Now, working in the team dynamic for a year long, that's a long time to be working on a team of 5 people. Doing research, designing, constructing, testing, doing the reiterations. What are you going to take away from the year-long project into as you start graduate school and furthermore begin your engineering career?
Well, as you mentioned, I am going to a graduate school, and so I hope to be doing a lot of researching with professors and other graduate students. So being able to work in a team is going to be really crucial to me. And even after I'm in graduate school, even once I move into the actual working world, it's going to be really crucial that I can actually interact with my coworkers.
How much fun did you have this year?
I had a lot of fun. I really enjoy designing and building things, so being able to actually build a senior design project like this and get it completed, get it all constructed, just being able to put everything together, just really, I had a lot of fun doing it. Now that it's all done, it looks amazing, and it just gives you a great sense of accomplishment.
Awesome. Well, that was Reed Goodwin-Johansson. We'll be right back. Welcome back to the Team FUNC Network. Of course, you know me, I'm John. Here I have with me Mara Noya. We're going to talk about one of the advantages here at NC State University. We do actual, not just senior design projects, but you actually build the designs. What would you say is the advantage of a project like this over going to another school where you only design a final project?
Definitely a big thing was the building aspect, especially in our testing. So in our testing we did a lot of different models, a lot of different designs to see exactly what would give us the best results. So instead of just relying on theoretical approach, we did a physical approach, and it really set the parameters for our final project.
Did you have fun with this final project?
I had a great time with this project. My funnest part was actually getting to build it. It's what I enjoyed the most. The design and everything was good also, but physically ordering all the parts, machining them, and building them it was a blast. And working with a team of great people really helped out.
Well, very good. Well, ladies and gentlemen, you heard it from Maria Noya. This is the Team FUNC Network. We'll be right back. Welcome back to the FUNC Network. Of course, you know me, I'm John. I'm here with our lead scientist and experimenter, Anna Winslow. Anna, first of all, let me ask you, what kind of advantages did you find from doing a design and build project over just a traditional design project?
Well, a lot of engineering schools just do the design aspect. And while it's great to see, okay, you can design something on paper, there's a lot of factors that you have to think about when you actually go into building a project. And sometimes as students, when you're not used to building things, you don't think about certain factors such as like, is it actually physically possible or is it feasible for what I designed to be actually built and used, and that kind of thing. So it helps you think, it helps you design in a way that you know what you design is going to be able to be built fairly easily and then actually used. And also, I felt like with our project we had an added area of complexity in that there was no real prior research that we could find on airtables. So we not only had the design and build aspect, but we also had a research aspect. So I felt like that was a really big advantage for us, that we learned not just, again, how to design and build, but how to actually solve a problem through trial and error.
Good. So the most important question now, Anna, did you have fun this year?
That's actually a funny question. You know, design is frustrating at times. Any project is going to be frustrating when you're doing something that you don't know how to do, you've never done it before. None of us had any experience, I don't think, in research and design and building things at this level. And it was actually, it's really important because this is a legacy project, so it's going to be used at NC State. So we really felt a sense of importance in what we're doing. So while there were those little trials and little frustrating moments, all in all, once you see the final project and we've gotten really great results on it, it has been a lot of fun, and all those little frustrating moments are totally worth it.
So there you have it from Anna Winslow, our lead scientist and experimenter. We'll be right back. I hope that what you have learned from this video is that here at NC State University, specifically in the Mechanical and Aerospace Engineering Department, we don't aim just to design something. We care about building it and testing it and seeking out further improvements to the design and being able to actually build stuff and gain construction experience to enhance our engineering education. You've seen that we went through multiple iterations, which is definitely relevant to the industry. And you've seen the times when we've had to redesign it. But all in all, it was an extremely rewarding project and a successful project at that. Thanks.
So I've been a part of Velocity, and as you can see, it just keeps spinning.
And after a year's worth of hard work, it's time to have a little fun.